Hey guys, this is Taylor here, and today we are solving the second problem of the contest, which is maximum total from optimal activation order. So this one is the third problem of the contest, and this problem is little vague. The description is not at all good, and even the example is incorrect. So if you observe, if you are able to understand the problem just in case, so you can observe that this is basically wrong. Here it should be 0, 1. So I have raised the issue in GitHub as well for the Leetcode. The team is currently checking that. So meanwhile, let's try to understand the problem. So I have written these two conditions which is given to us. First of all, we have given two arrays. First one is limit array, second one is value array. Okay, so this limit array basically defines the limit. This value array is basically the value that we can take from that current element. And what we need to do, we need to do some optimal operations to make every element. In best case, I need to make every element as active, and if I am able to make this 6 as active, I will add in my answer. If I am able to make this 8 as active, I will add in my answer, and whatever total answer I am getting, I just need to return that maximum possible answer. Okay, so this is the crux of the problem. And what is this vague thing? What is this very badly written thing telling us? So let me tell you. So it's telling that, let's read this, to activate an inactive element. Okay, to activate an inactive element at index I, the number of currently active element must be strictly less than limit. Okay, so number of currently active element must be strictly less than limit of I. So I have written this in a little simpler terms. So if let's say my limit is 10, okay, to activate this 2, okay, to activate this 2, what I need to do? I should like my current active, okay, so my current active count, I need to count current active. My current active should be either 0 or 1. If my current active becomes 2, na, if as soon as my current active becomes 2, I will not be able to activate this. My current active either should be 0 or 1. Okay, it should be less than 2. Okay, so if let's say I'm activating this 3, okay, I'm activating this 3. So my current active count, if 0, yes, I can activate. If 1, I can activate. If 2, I can activate. But if current active count is 3, current active count is, let's say, okay, if I activated this, I will make current active plus equal to 1. If I activated this, I will make current equal to 1. Okay, so in that case, if my current count is 3, I will not be able to activate. If my current count is less than 3, then only I will be able to activate the current number. Okay, so this is basically the description of first line. Okay, this first point. Now second point says that when you activate element at index I, adds value. So let me briefly tell you. So basically, if you are able to activate this, just add it in answer. If you are able to activate this part, just add in your answer, just add in your answer if you are able to activate. So this is basically the second point. The third point is again little vague. So after each activation, if the number of currently active elements becomes as x, then all elements j with limit of j less than equal to x. Okay, so if number of currently active elements become x, so my currently active elements, let's say 4, then whatever limit is less than or equal to 4 will become permanently inactive. let's say let's say so my active count is, let's say, so I have activated this for example, just for example, I have activated this four numbers. Okay, just for example. So okay, just for a simpleness, let me write something like, so I have activated, let's say, these two numbers. Okay, so I have activated this part and this part. Now, as soon as I have activated these two numbers, this will be discarded. Why this will be discarded? This will be also discarded. This will be also discarded. Why these numbers will be discarded? Because my current active is current active become 2. Okay, that's what it's telling. If current active element, so if we read here, if the number of currently active elements becomes x. Okay, so currently active elements, for example, for me, currently active is, let's say, x, and in that case x is my, let's say, 2. In that case, what I need to do, limit of j is less than equal to x becomes permanently inactive. So limit of j, okay, so any for any j, for any limit, if limit of j is less than, okay, so if limit is less than 2, then make it inactive. Okay, so that's what. So let me follow this condition. So my if limit is less than 2, I need to inactive, 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 inactive. So as soon as I have made this part, okay, this part is becomes active. Okay, first this will be active, then only I will be making this inactive things. Okay, so first I will compute this answer, then I will be trying to make what are elements are not active or inactive, all these things. So this is basically the description of the problem, and please don't go through this first example. This part is incorrect for now. So this is second and third example is correct. You can go through it if you want. Otherwise, I hope I'm able to explain you what is given to us in the problem. So let's see how we'll be able to solve this problem. So I have written these two examples, and if we are able to diagram on these two examples, we will definitely able to understand why this problem, how we will be able to solve this problem. Okay, so let's try to diagram on these examples. So let me write the current active count, and I'm not maintaining a total or answer or like that, because I'm not maintaining values array, just to make the problem little easy to understand. So because that will be very easy to calculate. So I am first of all here, my current active is 0. Can I make this as 1? Is the conditions are satisfying? So my current active count is 0, current limit is 1. Is this condition satisfying? Yes, it is satisfying. Okay, I can make this as 2. Let me make this as 1. I will move on. Okay, before moving on, I will make this one. I will check this condition. Make inactive if all limit, if all limit, what I have written, make inactive all limit if it is less than active count. Okay, so what is my active count? My active count is 1. So what I need to do? I need to make all of the limits which are having equal to 1. I need to make them as inactive. Okay. So I will be making this as inactive. So my active count will become 0. As soon as this reach this part, it will become 0. Why? Why this becomes 0? Because this is what my second condition is telling. So like if any I'm at current active becomes 1, then I need to make all the limits with 1 as inactive. Okay, this is what my question is saying, and this is basically permanent inactive, so you can't activate if you see. So then all elements j with limit less than equal to x becomes permanently inactive, even if they are already active. So I can't even able to activate this. Okay, I will not be able to activate this. Okay, so that's why I can move, I think, here, 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 and then I will be moving here in this part. Okay, and this was active, but later it became inactive. Okay, I hope that is clear. Now I am here, I am at 2. Can I make this 2 as active? So let me check the condition. My current active is 0 and my current limit is 2. Yes, okay, let's make it condition is satisfying. Okay, let me make current activate 2. Let me activate this. Super. I will move here. Okay, before checking that, I need to make all the elements inactive if it is less than 1, if it is less than equal to 1. So is there any elements with limit less than equal to 1? I think this all are basically inactive. This one is also inactive and this one is 2, and my current active is 1. So I need to make all the zeros and 1 inactive. Okay, so all the zeros and 1 are already inactive, so I don't need to worry about anything. Super. Now next thing, can I make this as active? I think yes, because my current active is 1. My limit is 2. Definitely I can make this. Let me make it. Okay, I have made this. I have made this. Now second part again. Make inactive if all limit if limit is less than equal to active count. Okay, so what does it mean? I need to make all the 0, 1 and 2. This current active is telling me make all the 0, 1 and 2 unactive. Okay, so this is inactive, 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 inactive. This was active. Let me make it inactive. Okay, this was active. Let me make it inactive. This was active, inactive, inactive, inactive. Okay, this 3 will not be. Till this part, I will be making all the elements inactive. Okay, so that's what the problem is. Okay, now I'm here. Okay, I am here. I need to maintain these pointers if I'm solving using sliding window or something. Okay, so my current in so I have made this two inactive, so my current activity will again become 0. Now in this 3, can I make this as a active? I think yes, current active is 0. This is current limit is 3. So I think you are able to understand the problem. In this part, I will be able to activate 3 numbers. In this part, I will be able to activate 4 numbers. If you are able to digest this thing, then you will be definitely able to solve this problem. So the crux behind the problem is only this part. So if the limit is 1, I will be able to only pick one element. If limit is 2, I will be able to pick only two elements. If limit is 3, I will be able to pick three elements. If limit is 4, I will be able to pick four elements. Let's try run for this 3 as well. Then we'll be better understand. Okay. Okay, let me dry run for this 3 as well. Then we will be definitely able to understand better. So my current, I think current count is 0. Okay, super. Now what I need to do, I need to basically activate this. Can I activate this? My current active count is 0. 0 is less than 3. Yes, I can activate this. Okay, let me activate this. Now current count becomes 1. Now the second condition, what it is saying? My current active is 1. I need to make all the zeros and 1, 0 and 1, make them inactive. Okay, it's already inactive, nothing to do. Super. Let me make this as active. Can I make it? Can I make it? 1 is less than 3. Current active 1 is less than 3. Yes, I can make it. Let me make it. Okay, my current active is 2. Now I need to make 0 and 1 and 2 as inactive. Okay, this is not bitwise AND operator. It's just AND. Okay, simple AND. So I need to make 0, 1 and 2 all are inactive. They are already inactive. I don't need to do anything. Okay, let me come here. Is 2 is less than 3? Is 2 current activity is 2? 2 is less than 3. Yes, it is. Let me make this active. If as soon as I make this active, current active count becomes 3. If current active counts becomes 3, I need to make all the elements including 3 as well as inactive. So I will make this inactive, this inactive, this inactive. So that way, I think with 1 I can able to pick 1. With this 2 I will be able to pick 2 elements. With this 3 limit I'll be able to pick 3 elements. With this 4 I will be able to 4, and so on, so on, so on. If you are able to see this pattern, you will definitely able to crack this problem, and this part is very easy. So here you will be taking definitely one element, whatever value is. Here also you can take maximum of 2, but only one is present, then you will be taking the maximum. You will be taking the value, whatever value it's okay. And if we need to solve it optimally, okay. So if let's say values are something like this. So if let's say let me quickly erase it out. Super. So let's say my values are like this: 2, 4, 6, 8. 2, 4, 6, 8, 2, 4, 6, 8, and 2, 4, 6, 8. So I think I can take only one element from this one area. Which element I will take? I think I will take this 8. Okay. I think I can take only two elements from this area. Which one I will take? I think I will take this 2, right? Maximum. I think I can take three elements from this 3. I think I will then I will definitely take this 3, 4, 6, 8. I can take all 4. Okay, take all 4. So that's what. So the core intuition, the core idea behind solving this problem is this part only. If you're able to correct this part, then definitely. Now you might have guessed that we can use something like heap. So one solution lies behind the sliding window approach. So whatever we have discussed, you can solve this part as a sliding window. You can take a left pointer and you can maintain a current active and current pointer, and you can make left pointer. So that is little complex to understand, but the heap approach, the priority queue approach is very easy. So I will be just maintaining my core idea behind solving this problem is the first part. If limit is equal to n, I can take max n elements. Okay, so my core idea is only this part, only this part. If I'm able to reach this part, I will be definitely able to write a priority queue and able to solve this problem. So what I need to do, I need to make a priority queue. Okay, my priority queue will something like this. So let's say for one, okay, I'm making a dictionary. I'm making a hash map. For one, what all values I'm having? I'm having 2, 4, 6, 8. For two, I'm having 2, 4, 6, 8. For 3 also I'm having 2, 4, 6, 8, and for 4 as well I'm having 2, 4, 6, 8. Superb. Okay. So what I need to do? I need to just take the maximum from here, maximum from here, maximum from here, and maximum from here. So what I will be doing, let's try to write some pseudo code so that we can understand how I will be writing the code, the code logic. So what I will be doing is basically I will make some priority queue. Okay, so that will be empty initially. And what I need to do, I need to iterate over the list. Okay, and I will create the hash map first. Okay, I will create this hash map first. Okay, so let's say create hash map. My second approach is, first part is this, create hash map or dict, whatever you can say, and what that hash map or dict will contain. So these are basically limit, and this is basically the respective values of those limits. Okay, and now my task is really simple. If it is 1, I need to take top 1. If this is 2, I need to take top 2. So what I will be doing, I will be just taking this thing. So for each limit, for each limit, get the max number count equal to limit. Okay, so for 1 I need to take only first maximum. For 2 I need to take top 2 maximum. So I hope the approach is clear and intuition is also clear. Pseudocode, I don't have nothing, like I don't have much to write. So we'll be seeing in the code. If you write in C++ or Java or JavaScript, so code is in description, a similar code. You can definitely go and check it out. So let me write my priority queue and dictionary. So my dictionary I would be calling, I can take it name is, I think, limit to values. Okay, because it's basically limit to values. This is basically the limit part, and these are the values. Okay, so limit to values, it's, let me make a default dict, and its by default value will be list. Why list? Because this I'm storing all the lists here. Okay, list elements. Super. Now I need to import heap also. Heap queue, okay. Heap queue is basically priority queue. Now what is the next thing I need to do? I think I need to iterate over the numbers, and after iterating, what I need to do? I need to basically check. I need to basically check. I can simply, I think directly I can add it. I can add the current number, okay. So let me add it. So to add the number, so I think heap queue dot heap push, and what I think I can do something like this, limit to values of limit of I. So what I am doing here, let me explain you. And I think value of I. Okay, so what I'm doing here, basically I'm checking. Okay, if it is limit 1, if it is limit 1, I'm asking, give me its list, give me your list. Okay, I'm asking the dictionary, give me your list, and whatever list it gave me, I'm just appending the current number. Let's say 10 comes, so I will just append this 10. Okay, I will just append this 10. Now what is the second thing I'm doing? Second thing I am doing is, so this is heap. Okay, this is heap. So what is the next thing I can do? I think I can do this part. If length of this part, length of my heap becomes greater than the limit of I. Why? Because for one, I need to just store the maximum one. For 2, I just need to store only maximum 2. For this 3, I just need to store maximum 3. That's why as soon as they become this, heap q dot heap pop, I can pop the elements, and I just need to give the heap name, and what is the minimum value, it will be popped. Okay, now I can calculate my answer. And how I can calculate my answer? So whatever value, so after this my heap will something looks like this. My heap will look like this. So heap, so basically I'm using a little complex data structure. This is my dictionary, this is my hash map, this is key, this is value, and with these values are basically heap. This is heap, this is heap. Okay, this is heap. So my resultant answer will something look like, 1 will be having only 8, 2 will be having only 6 and 8, 3 will be having only 4, 6 and 8, and 4 will be having 2, 4, 6, 8. Okay, so if you're not able to understand this part in Python and you write code in other languages, so make sure you follow the code in description, you will definitely able to understand. So what is the next thing? I think for heaps, for heap in limit to value dot values, and I can just add my answer plus equal to sum of whatever the heap sum is. I can definitely return a answer, and one thing we are missing is taking the length of value, and I think we are good to go. I'm pushing. Okay, let's try to run this. Okay, it is working fine. Let me try to submit it and see whether it is working fine or not. Okay, yes, it is working fine. And the time complexity and space complexity will be n log n because we are making a heap, and space complexity will be around order of n because in the worst case my heap can contain all the elements, which is order of n, and this dictionary also. So I hope you are able to understand this complex and vaguely written problem. In case you did, please make sure you subscribe the channel. That will motivate me to create more such insightful solutions and easy to understand solutions. So thank you very much guys for watching this video, and please don't forget to subscribe and give a thumbs up. Okay, thank you guys.
Hold me close till I get up. Time is barely on our side. I don't wanna waste what's left.